Hi friends, we are talking about semiconductors and it's about last minute revision of chapter 14. So let's have a quick view.
Before moving ahead, just see the classification of metal on the basis of their conductivity or resistivity and energy level. So what happens on the basis of conductivity? Metals possess very low resistivity, means high conductivity. Insulator have high resistivity or low conductivity, and semiconductors are intermediates. Energy band gap between conduction band and valence band is overlapping in conductor. It is somewhat wider in semiconductor and it's very wide in insulators. You come across this four word very frequently while studying electricity or electronics, that current, electrons, energy and controlled. So how it works, let's see. That any circuit requires current, and for that motion or movement of electron is very necessary, and it happens only when we provide external energy like light and heat. But everything should be controlled, otherwise there will be disaster. Earlier people were used diode, triode, pentode, vacuum tubes, which were also called valves. But what happened, that devices were bulky, very low reliability, very short lifespan, operated on very high voltage, so it was not convenient. Fortunately, unique properties of semiconductors were noticed. In semiconductors, valence electron can move freely if we provide external energy. And there are two types of semiconductor, intrinsic and extrinsic. Intrinsic semiconductor are pure form, and extrinsic means some doping is there. Doping means mixing. If you add some impurities, property of semiconductor will be enhanced. Because at 0 degree Kelvin, intrinsic semiconductor behaves almost like insulator. So in extrinsic semiconductor, if we mix pentavalent impurity, what happens? That N-type of semiconductor will be formed. N-type means number of electrons will be more than number of holes. And if we mix trivalent impurity, in extrinsic semiconductor, P-type of semiconductor will be formed. P-type means holes, means donor impurity will be more. One more thing, for intrinsic semiconductor at equilibrium, Ne is equal to Nh is equal to Ni. Ne is equal to number of electron, Nh is equal to number of holes, and Ni is equal to intrinsic carrier concentration. For extrinsic p-type, NeNH is equal to Na square. And loss of electron to N region and gain of electron to P region generates barrier potential. Ed is donor impurity energy level, Ec is equal to conductor impurity energy level, Ea is equal to acceptor impurity energy level, and Ev is equal to valence band energy level. So when we apply external energy to semiconductor, what happens? That due to that energy, valence electron moves from valence band to conduction band and leaving behind the holes. So that holes attract another electron, and this simultaneous process of combining holes with electrons generate current. And hence for intrinsic semiconductor, I is equal to IE plus IH, where I is equal to total current, IE is equal to electron current, IH is equal to hole current. Do remember that hole current is a just conventional method to describe the current. Generally, hole doesn't move. So now coming towards p-n junction formation. What happens? Junction is a boundary or interface between two types of semiconductor materials, N-type and P-type, and P side contains excess of holes and N-type contains excess of electrons in outer shell of electrically neutral atom. Towards p-n junction formation, when holes diffuse from P to N, it leaves behind negative charge, which is acceptor, and it is immobile. And when electron diffuse from N to P, it leaves behind ionized positive charge, which is called donor, and it is also immobile. And due to this process, diffusion current arises, and positive layer is developed on negative side of junction, and negative layer is developed on positive side of the junction. And this space charge region developed on either side of the junction is known as depletion region. Since impurities and semiconductor both are electrically neutral, p-type or n-type are electrically neutral, and when you study junction transistor, do remember that n-type acts as emitter and p-type acts as collector. And potential difference required to move electrons through electric field is called barrier potential, which is different for different material. Due to depletion barrier, opposite electric field is generated, and that's why current in opposite direction is generated. That is called drift current. Initially, diffusion current is very large and drift current is small, but the process continues till drift current and diffusion current becomes equal. This state is called equilibrium state. So in this video of semiconductor, we have studied classification of solid, characteristics of intrinsic and extrinsic semiconductor, p-type, n-type semiconductor, and junction formation. So that's all for this video. Thank you.